It's the gift that keeps on giving. For me, I have a winter break, and for you all, I have a new video. This is an animation script tutorial all about mixing and matching move particles. So this tutorial is more so going to be a couple of examples that I will walk you all through. We will be starting with existing move animations, and then make our changes on top. For the moves, we'll be replacing singular move particles, and then we will talk about OAM data, which is related to the different sizes of the sprites, and then we'll be replacing multiple sprites with a singular sprite, and this is related to understanding animation frames. Admittedly, these objectives are probably not written the best, but as the exercises get harder in this video, you will notice the new obstacles. To find more HMA tutorials, click Help and then click Tutorials, or Event Script Reference. You will find so many tutorials written by members of the community that can guide you through different aspects of ROM hacking. In addition, it's best practice to back up your ROM regularly so that you're not punished for making mistakes. On your keyboard, do Ctrl and E, and you'll notice a message box that wants you to talk about your most recent change. I'm going to type something in this box that foreshadows something later in this video. Once you're done, press Enter and your backup has been created. In the folder that has your ROM, go inside the Backups folder. Inside you will see a fresh copy of your ROM and its .toml file. If you mess up your ROM hack in any way, you can go back to this backup at any time. So the first example is going to be pretty easy. We are going to make Aurasphere, similar to this move animation in Pokémon Glazed. I just modified the first partner Pokémon to get Aurasphere at level 5. Let's try to recreate this move animation. So I'm first going to start by going to the move particles table the same way I did in previous videos. In case you need to make more move particles, go to the very bottom of the table and click Add One New. You might see 2 different sets of data moving to a new location, and that's totally fine. For both the new sprite and palette, you will need to change the index value to a unique number. So in this case, I will change the duplicate white rings to this first unnamed value. Then I'm going to scroll up to decide what to use to make Aurasphere. I mean, I already gave away the answer, but there are different ways you can make this animation. I could repurpose Shadow Ball's move particle like what I did here to make stored power, but instead, what I will do is use Shadow Ball's animation as a base and change the particle and its color. The choice is pretty much up to you. What I will be doing is using the Barrage Ball move particle and coloring it red. For now, we will stick to particles that are just one picture instead of multiple in a table. Alright, I think I messed up something, so I'm going to have to go back. But in the sprites table instead of the palettes table, I'm going to copy the pointer to Barrage Ball's sprite and then paste it to overwrite the new particle's pointer. Now we have 2 pointers to the same Barrage Ball. Now we have to decide on a palette to use. Usually this is just trial and error, but it helps that some palettes have similar color schemes to each other, especially in terms of the order of colors. I'm going to navigate to the pointer of X Impact's palette, copy it, and paste it over here. And look at that, we have an almost perfect Aurasphere ball that's colored bright scarlet. It almost looks like a tomato. Before making any edits, click repoint this one twice. You will not regret it. Alright, I did notice one imperfection here and I'm going to fix it. The bottom of the ball looks pretty jagged, and it turns out there's an extra black color. I will change it to another red color to make the sphere look more spherical. Alright, I'm happy with how the sprite turned out, so I'm going to save changes and move on to the next step. So off screen I already implemented the rest of Aurasphere's move, like the stats and the move description. Now I'm just going to go to Aurasphere's move animation. All of this code that you see here is actually Shadow Ball's move animation. I just copy and pasted code from the vanilla game. I made sure that this code is in free space too. I'm going to first change the load sprite graphics argument. Every particle index starts with 10, and I just put in the new particle ID. If you're changing multiple sprites in an image, you will need multiple load sprite GFX commands. Next, in this create sprite command, I'm going to change the pointer here to another address in free space. How do you know which create sprite to change? You kind of have to guess based on the order of pictures that show up when doing the regular move animation. Since I have Aurasphere's sprite and palette at index 10289, I'm going to change the tile tag and palette tag to 10289. This will also fix 4 out of the 5 red pointers that you see to the right. I also want to focus on this OAM parameter here. If you're switching move particles that have different dimensions, you need to get this pointer correct. The first thing you need to do is check the length and width of the particle you were replacing, so in my case, Shadow Ball's ball. So I'm quickly just going to the move particles table and navigating back to Shadow Ball's sprite. Now in the image editor, be sure to zoom in a bit and notice these gray boxes that are dividing up the sprite. Each box is 8 by 8 pixels, so you just need to count the number of boxes wide and the number of boxes long. For Shadow Ball, I see 4 boxes wide and 4 boxes long, so the sprite is 32 by 32 pixels. For Barrage's case, we lucked out. The sprite is also 4 boxes wide and 4 boxes long, so we don't actually have to change the OAM pointer here, but sometimes you do have to do it. In another example, I will show you exactly what you need to do in order to find the correct OAM pointer. You basically have to go to a website that I'll link in the description. Anyways, I'm going to round out the rest of this move animation code. Here's a trick that makes using move backgrounds more streamlined. I'm going to use the fade to BG from set command so that I can put in all 3 different solar beam backgrounds, so the light focuses on the correct corner of the screen, whether you're in a battle or a contest. As far as I know, they really only used this command for Guillotine's move animation. They could have used this for others. Actually, these are all the changes I want to make. You can actually go further by changing the sounds or introducing new visual tasks, which can be their own videos in the future. Let's see Aurasphere in action. Press F5 on your keyboard or the green play button to open MGBA, and take a look. Shoot, I made a mistake. Nothing was wrong with the Aurasphere itself, I just mixed up the light backgrounds. That's an easy fix though. Take number 2. Fantastic, now we got a formidable fighting type move. Here's another exercise. This one's going to talk more about OAM data. Let's make a cotton guard, but use Cotton Spore's animation, but with even softer bits of cotton. Let's first retrieve Cotton Spore's move animation by going to it. Similar to the next objective, you're going to see 2 sections of code, and I'm only concerned about the top section for now. We will get to the bottom of it pretty soon. I will copy this code, go to an area in free space. Also, as you're continuing to ROM hack, it'll be easy to recall which addresses in your ROM aren't being used. And then paste the code. Hex Maniac Advance will automatically show the second section of code I talked about earlier. Since we're going to make some edits to this section, we also want to make a copy of it so that we leave the original one untouched. I will skip a couple of rows of free space, choose this address, and paste again. Next, I'm going to copy this address that I just pasted code in, and in the first section of code, you will see 3 call commands. There's an address inside each command's pointer. I'm just going to paste over each one. Once that's done, this animation code is pretty much safe to edit, however we please. Right now, this move animation is just going to play Cotton Spore's animation. We need to change these sprite templates so that they use a different particle. In each create sprite command, I'm just going to replace the existing address with a new address in free space. 3 times. What exactly are we going to replace those cotton balls with? Well, in my head, I was thinking of the cloud that shows up when you use the move yawn. So I'm going to search for that move particle in the particle table. I'm going to click this bar over here that currently says bone, and I'll search for cloud. And there's a pink cloud one right over here. You will need to pay attention to the ID, which is 242. Yep, for this example, we don't need to make a new particle. We can just use what's already in the game. Also note that this sprite is 32 by 32 pixels because it's 4 boxes long and 4 boxes wide. So, going back to Cotton Guard's animation script, we can now make a couple changes. We can change both tags to 10,242, and we will also have to change the load sprite GFX command to match that ID as well. Now is where we talk about the OAM parameter again. For the spores used by Cotton Spore, this address is 52490C. If we leave it like this, there will be problems. What we need is a special database of information, like this one. This website contains a lot of information about Pokémon Emerald, and there's also a version for Fire Red and Leaf Green as well. I will have these linked in the description. There are a lot of numbers and letters here, and you don't have to read all of them. I'm going to do Ctrl F to load the Find tool, and search for the OAM address that you found and need to change. that address corresponds to this data. We can infer without looking that the cotton spores are 16 by 16 images. What we want is the same OAM data for the dimensions of the new sprite, which is 32 by 32 for the cloud. To the left, you're going to see the right address, which is 524914 for me. I copied it and I'm going to return to Hex Maniac Advance. And I'm going to paste this new OAM pointer over the old one. And that's all you pretty much need to do, but there are some more notes I want to go over. If you scroll down a bit in this website, there are so many entries for OAM data, even some for the same sprite dimensions. But for this tutorial, I specifically chose this 32 by 32 replacement, because it's in the same group as what was there before. When it comes to groups, there's a group for affine offs, affine normals, affine doubles, and a few more. Basically, my point is don't mix and match those groups. In a vast majority of cases, you don't need to do this. With that aside, let's test out our move. Oh no, I made a mistake. It's not supposed to target the Tropius, and OBS is not supposed to lag. It turns out nothing was wrong with the move animation, I just forgot to make the move target the user in the moves table. Guys, this is why it's important to thoroughly test your stuff, just in case there are some oversights like these. Let's use this move one more time, and yes! The cotton clouds are in the right spots, and they don't look chopped up whatsoever. Needless to say, I am happy with how this animation turned out. Here's a harder exercise, replacing multiple particles with one particle. I will start by going to Rockslide's move animation. I will first double-click this pointer to get to the code, and then select this first block of code. As you see here, there is another section of code, and I will ignore it for now. Just focus on this section up here, and I'm going to paste it to an address in free space. Click the magniglass on the bottom left, and specify a large number of bytes of free space to look for. And then you will want to go to this code text box over here and paste the code. You're going to see some more code show up automatically. We will work with this code in a little bit. At this point, you're wondering what I'm trying to show you. And the goal is to use Rockslide's move animation, but with upside down icicle spears to make Icicle crash. So yeah, I was retrieving the address of this new animation script that I copied and putting it into Icicle crash's move animation field. In other words, I did stuff in a different order, and that's a-okay. So Rockslide has a section of code that's being called twice. And I'm going to copy all of that code this time. I'll just pick another address close by in free space, and then paste the code over here. I will then right-click the first byte of the code and click Copy Address, and then go back to the first section and paste it right here after each call command. I almost forgot I need to make an upside-down Icicle Spear image, so I'm gonna go to the Move Particles table, and then find Icicle Spear's vanilla move particle, and I will first copy the sprite pointer and its size. And over here, it turns out that sprite 293 is unused, so I'm just going to paste the stuff over here. Okay, I will need to backtrack to Icicle Spear's move particle so that I can retrieve its palette. Like before, I'm just going to copy and paste it in its correct location. Also, like before, click repoint this one for the sprite and the palette so that you don't mess up Icicle Spear's move animation. And I'm going to edit this new particle. What I'm gonna do first is just move the sprite down 1 pixel to keep it centered, and then I will flip it vertically so that the sharp point faces downwards. So back in the code, I'm going to create a new sprite template in free space. Note that I'm not replacing any pointers to templates that have title tag 0 and palette tag 0. Those can be left alone. There are many pointers to replace, so please bear with me. Okay, I think I got all of them. So Rockslide has 1,000 falling rocks, and we can change these two numbers so that the falling objects are icicles instead. I put the new sprite at index 293, so I'm going to change these tags to 10,293. This time for the OAM pointer, we don't actually have to change anything, because both an individual rock and an individual icicle are 32 by 32 pixels. When I go to the small rocks move particle, I will need to adjust the slider on the top left so that the rocks don't look like a jumbled mess. But you can see that even as the rocks get smaller as you go down, each one occupies a region of 4x4 boxes, and even though the Icicle sphere is a single image, it's also 4x4 boxes. Alright, I think that's everything we have to do. Now we just gotta show this move animation in action. Oh. Oops. I forgot to load the right sprite graphics. Okay, surely the animation will work normally now that I made this simple change. Guess not. What even are these things? They look horrendous. Okay, this is a big problem. So, I know what the problem is, but it took me a while to figure out how to solve it. Look at this anims field. Turns out this has to be examined. Because the small rocks are all in a column, the animation needs to know which rocks to pick from, and some of it is handled here. We need to change these animations so that it only uses the single Icicle crash particle instead of trying to find non-existent particles that look like garbage. So let's go to this address and see what's in store. In the case of Rock Slide's move animation, you're going to see 3 pointers. It's not always going to be 3, there might be more or less. Let's follow this first pointer and clear its format, it's not text data. Now, let's look at these 3 values. There's a 20 byte, a 30 byte, and a 40 byte. These numbers correspond to different frames, in this case, different rocks. With this information in mind, the goal will be to make a copy of it, but with some slight changes. Back in Icicle Crash's move animation script, I will pick another address in free space and type another pointer to free space, as you see here. Then I will copy this 2 more times, because the original anims had 3 pointers. These 3 pointers start at 31D420 for me, so I'm going to change the anims pointer to that. And that did nothing. Hold on, what if I go to the bottom and change it there? There we go, that worked. You have to change the last one because, in a nutshell, HMA recognizes a data conflict, and the most recent version of the data wins. Start typing 0000 to indicate the first animation frame, which is the only one we have, and then 0100 to indicate a time which we don't have to change, and that bit of data ends with FFFF0000. And that should be the magic antidote that fixes everything. Let's save changes and view the avalanche. That's not the right move we were working on, but comment if you didn't get what I mean. Let's beat up another Ninkata. Amazing. It's glorious, visually appealing. As you keep making more custom move animations, you'll slowly start branching out to exploring different parts that can be manipulated, so that your newer moves could do all sorts of things. It makes experimenting a whole lot less constrained. Now, I could stop the objective here, but since it's the holiday spirit, I've got a bonus treat for you. Let's change the sound effects so that it looks like icicles falling down instead of icicle-shaped rocks. Throughout the code, you'll see play SE with pan commands that mention the rock throw sound. We can change each and every one of them so that they reference icy wind sound instead. This is going to take some time, so sit tight! Now we're going to have the same completed move animation as before, but now it's going to sound different than what Rock Slide normally sounds like. This one is another successful move animation. We could keep going with more elaborate move animations, but I think these examples are good for this video. And there's more to talk about in animation scripting. I don't really have much more to say here. Thank you, my viewers, for making it to the end of the video. You have learned different ways of manipulating move particles within existing animations, so you can make just about any sprite move however you want it to. This opens up a lot of possibilities for how you want to animate different moves, like some of these custom moves I'm showcasing right now. Everything that I've shown off in these 3 examples can be applied to other combinations of base moves and move particles. I've always been passionate about animation scripting, and I like sharing my knowledge with other ROM hackers. I hope you guys liked this video. After Christmas, I'll have more videos in the works, so be on the lookout for those. As always, my viewers, don't forget to like, comment, and subscribe, and happy holidays!